Hello everyone, welcome to today's class. I'm Uchechukwu Promise. Over the years, I have faced depth moved from confusion to clarity. Growing up into a family of teachers, I've learned that education is not about acquiring results, but shaping minds and building confidence. Being able to defend our good results anywhere you find yourself. That's the experience I want you to have in this class. A man said, education is a vital investment in every society that wants to grow. Former presidential candidate Labour Party, Mr. Peter, education is never a scam and will not be a scam and forever not will not be a scam. Join me and get the educated mind. Okay, and today we'll be diving into an interesting topic on physics, titled Introduction to Physics. Why is this very important and special? Foundation is very important in every field of life. If you have a weak foundation, you are bound to collapse on your way. But if you have a strong foundation, you will go far. That's why I enjoy you today to join me as we build a solid and strong foundation of physics. Thank you. Introduction to physics. First of all, let's look at etymology of physics. Physics, this word physics is coined from a Greek word physis. If you look at the word now, we see that they have the same pronunciation, physics, but their spellings are what different. And the physics also is also coined the word physical is coined from it, physics, physical. And this word physics means nature. So that's to say that in physics we study about what? Nature. What is nature? Nature is anything we can see and touch. Literally going by this word or term nature or term nature, physics is the study of nature and natural phenomenon. That is the literary meaning of physics. But that is basic or elementary definition of physics. Then in advanced definition of physics, because why is it basic? It's limited in various aspects of what? Physics. It doesn't explain more on physics. That's why it's what? Limited. In your external exam, please, I beg you not to use this word to define physics. In case if you're asked, define physics. Please don't use that word. That word has limitation. I will give you this advanced definition. Take it to bank and write it whenever you are sitting on a exam. Physics is a scientific study of nature that relates with the matter, how energy is transferred, and their interaction. Or you simply say that physics is the natural study of matter, how energy is transferred, and their interaction. This one comprises of many things because when you talk of matter, matter is anything that have with and occupy space. That is also related to what? Nature. Then how energy is transferred. In physics we study about what? Energy. Okay? Kinetic energy and potential energy and rest of them. So, it's also it's also embedded what? In physics. And their interaction with their environment and what? External bodies. Okay? Then we have two branches of physics. Okay, before I go to the branches of physics, let's look at why this physics is important. This physics help us to know how and why things move, why energy is transferred, and how the force affects an object in universe. Okay, and also physics also help us to study the world around us, ranging from the sound of our voice, and the motion of the planet. Also, physics help us in problem solving and logical thinking. Physics is the foundation of other science what subjects like chemistry and biology. We will still treat it. We have biophysics, okay, and other subjects, science subjects have what good relationship. Okay. Also, physics help us to in construction. It help us what in construction industry like roads and and many other things, building and road construction industry. Physics also help us in technological innovations. It help us in technological innovation, the invention of phones and other gadgets through the application of what? Physics. Physics also help us to understand natural laws. It help us what? To understand natural laws. Okay. First of all, the application of physics in our everyday life. Physics help us to light our houses. This light you are seeing on my background, the studio light that lighting up my work is done with the application of what? Physics. It's achieved with the application of physics. Okay. Let's go to branches of physics. We have two main branches of physics, which is classical physics and, and modern physics. This classical physics, this classical physics is the physical study of ordinary space and sizes. Example of classical physics, we have mechanics. We have mechanics. In mechanics, we study about motion and force. Then we have heat and thermodynamics. Then we have light or optics. These are some of the examples of what classical physics. Okay, we have modern physics. Modern physics is the study of phenomena from the small to what or higher scales. Example of modern physics, we have quantum physics, we have particles physics, we have nuclear physics, we have relativity. These are examples of modern physics. Then physics relies on measurement. What is measurement? Measurement is the process of finding a size, quantity, or amount of something by comparing it to a known standard. That standard is what? SI unit. This SI unit is coming from a French word which is System International their unit, which is translated as International System of Unit. Is adopted in the year 1960 as International System of what measurement that is globally what accepted. And this SI unit include quantities. We have two types of quantities in physics. We have fundamental quantities and derived quantities. Fundamental and derived quantities. These fundamental quantities is also known as what? Base quantities. These base quantities they are independent. they stand alone. They don't need any person. No. They are what naturally what occurred. They stand alone. They are independent. They are not being derived from other quantities. They occur by themselves. Rather, other quantities are being derived from them. Okay? And these base quantities or fundamental quantities there are 7 numbers. Number one, we have length. We have length. A meter represented the capital letter M. We have mass in kilogram represented with kg. We have time in seconds represented with capital letter S. We have temperature in Kelvin represented with capital letter K. We have amount of substance represented with letter represented with moles, MOL, which is the unit of what? Mole. We have electric current represented. We have electric current represented with letter A in ampere. Remember, this is called what? Unit. This thing here is called what? Unit. Unit. I said before that this SI unit quantities is embedded or is inside the what? The unit. So this is quantity. This one is quantity. Quantities. This one is unit. And this one is symbols. Quantities, units, and what? They are symbols. Okay. If you count it, it remains one. Luminous intensity, which is its unit is what? Candela. Candela represented with C D. If you count it now, is 7 in number. 1, 2, 3, 4, 5, 6, 7. There are what? 7 number. They are called base quantities or fundamental what? Quantities. Then we have another one called derived quantities. We have another one called derived quantities. These derived quantities, as the name sound, derived. We have another one, derived quantities. As the name sound, derived. They are being gotten from fundamental quantities. Okay? Example of these derived quantities, we have what? Area. We have volume. We have speed or velocity. We have force. We have work or energy. We have acceleration. We have pressure. We have power, and so forth and so on, etc. Okay, this is the what? Some of the derived quantities we have in physics. Okay, let's go over to how to derive these quantities. Let's go over to how to derive these quantities. Let's look at derived quantity step by step, one after the other. For example, we have quantities, we have definition, we have SI unit, we have base unit, we have dimension. Let's start with area. Area is defined as length times breadth. Remember, when we are talking about length is what? In meter. Mass is in kilometer, and time is in seconds. So these are the basic units, as we say, or base unit, as we all know. So our these definitions will be represented with SI unit. It must be in length, or in mass, or in time. These are what? The basic, or the three main base quantities. It must be in mass, in length, and in time. Please, are you with me? Follow me. For instance, we have length here. Length is what? Length is in meter. Breadth. Let's know whether breadth is fall in a category of length, or in mass, or in time. Follow me. Let's looking at this rectangular shape, we will discover that the breadth the breadth is the shorter form of what? Length. So because the breadth is shorter form of length, is also length, longer length and shorter length. So it's also in what? In length. Is what? In meter, because it's shorter length, which is called what? Breadth. So finish representing this like this. We have m times m, which will give us m square. Then our SI unit is m square. Then our base unit will be m square. Then our dimension, we are also using the three main base quantities, which is what? Length, mass, and time. We use their first letter alphabet. Their first letter alphabet. Length in L, mass in M, and time in T. So because our M, which is in meter, stands with what? L. We represent it with what? L square. This is our dimension for area. And whereby there is no L, or there is no M, or there is no T, we will represent it with L or T raised to power 0, M raised to power 0, L raised to power 0. signifying that there is no what? Time, mass, or length. Okay? Then please, while placing your list to put as 0, please, it will not be at the back. It must be at the front of that letter. This is bad, this is bad, and this is what? Bad. Please don't do it what? This way. Okay? Let's go over to what? Volume. Let's go over to volume. Volume is area times height. As we all know, we have gotten our what? Area. We have gotten our area, which is what? Length times breadth. Representing it in this form, we have length times breadth times height, which is what? Our volume. We represented this area with this one, giving us what? Length times breadth times height. Then we have gotten our length and breadth as what? M times M. So let's know what is height. Height is the distance from one gap to the other gap. The distance from one gap to the other gap is what we call what? Height. For instance, the distance from this board to this down board, the distance from this edge to this edge is what we call what? Height. And it also deals with what? The length of this place and this place. So height is represented with what? L, which is equals to what? Meter. So we represent H with M, giving us what? M times M times M will give us M cubic, or M raised to power what? 3. Do it this way. M raised to power 3, which is our SI unit. Then our base unit is M raised to power 3. Then our dimension is L raised to power what? 3, because M stand for what? Length. And length have the L as the first alphabet, which is what? Our dimension. Okay? Please follow me. We have another one. Velocity is the distance over time. Okay. Then what is distance? Distance is the speed covered in a specific time. It's a speed covered within a specific time. We call it what? Distance. Mathematically, distance is a point ranging from this point to this point. For instance, a car traveling in a distance of 2 meters. Assume that this is a 2 meter. That this 2 meter is the length covered within a specific time. That's to say that our distance is what? Length, which is what? Meter. Then our time is seconds. Okay? Then if we substitute it with this alphabet, we have M, or let's go with this one, L divided by T, which is equals to M divided by X, which will give us meter per second. Then this can be right, but it can also you can also change it to base unit. This is SI unit, meter per second. You can also change it to base unit, which is what? Meter per second. If you change it to base unit using negative index in law of indices, that is law 7, we have the law of indices law 7 which is negative, they state that any number raised to power minus any number is equal to 1 over that number raised to power what? The same number. This is the seventh law of indices, law of negative what? Index. Applying it on this problem, we have, let's focus on denominator, which is what? S. If we bring S, 1 over S, then we have converted to be in this form. That's to say that this thing is equal to S raised to power of 1. Okay, multiplying it with this one, we have S raised to power of 1. You can choose to do this way. M times 1 over S times we have what? M S times S is what? Minus 1, which is what? Our base unit. Okay, then putting it into our dimension, we have our dimension. Remember, when we are talking about dimension, we are talking about 3 base units, which is length, mass, and time. Remember, they use their first alphabet, which is what? In capital letters. You can see it here: length, mass, and time. Okay. Then when there is absence of any number or raised to power number or index on this side, you represent it what, like with 0, such like L raised to power 0, M raised to power 0, and G raised to power 0. Please take note, 0 will not be at the back of the alphabet. This is wrong. This is wrong. This is also wrong. It will not be at the back of alphabet. Rather, it will be in the front of that alphabet. Then, converting this thing into a dimension, our M in this aspect is what? Length. Then our S in this aspect is what? Time. Then converting it, we have what? L T minus 1, which is what? Our dimension. You can also say is M0 L1 T minus 1, because this thing have hidden minus what? 1. It have hidden, it have hidden raised to power 1. You can also choose to write it this way: M0 LT minus what? 1 is still what? The same thing. So a very strong foundation of mathematics for you to be able to understand physics very well. Okay, let's go to mathematics, which is what? Let's go to law of indices. The seventh law of indices, which is negative index. Using negative index, we say that any number raised to minus any number is equal to 1 over that number raised to power that number. This is what the negative law of indices, negative index. Putting it in this medium, we will be considering the denominator only, which is what? For now, we will be considering the denominator, which is what? X, which will give us 1 over S. We have transformed it in this form, 1 over S. Remember, this thing is equal to this or equal to this. That's to say that this thing can be this form or this form. Putting it, we have S raised to power what? 1. Okay, and which is the same thing like saying let's multiply M, which is what? M 1 over S. This is multiplication table.
if you times it, it's still the same thing, like saying is ms raised to what 1. If I don't wish to follow this way, I will go this way. I will first of all do this to 1, then bring back the m. It will be m times s raised to power 1. Anytime you see this dot in mathematics, know that this dot represents multiplication. Then which will give us m times ms raised to power 1. Then having gotten down, our SI unit is m per seconds. Then base unit is ms raised to power 1. Then let's look at our dimension. Our dimension is we have m, we have t, we have m and t. So let's represent it here. We have m t minus 1, which is what? Our dimension. We can also write it this way. Can also write it this way. Or L raised to power 0 m t minus what? 1, indicating that there is no what? Length. Indicating that. Let's continue with acceleration. Acceleration represented with the small letter a. Acceleration is the change in velocity over time, or change in velocity over what? Time. This is delta v over time. Then we have our velocity, which is final velocity minus initial velocity divided by t. Then because we are considering velocity as a whole, then our velocity is distance over time. Our v, which is equal to meter per seconds, which is also meter ms raised to power minus 1. Okay, we have got our velocity. Then we substitute with this formula. We have ms raised to power 1 minus 1 divided by s. Okay, this will be equals to ms minus 1 times s minus 1. If this division time go over to this place, it turns to what? Multiplication sign. And whereby we are applying the first law of indices, which is what? The seventh law of indices, which is negative index, that will be what? Minus 1. And the first law here we will apply the first law of indices, which is the multiplication law, which say that when we have two the same base in a multiplication signal, then we add the index. So going by that, we have ms minus 1 plus minus 1, because we take what? One of the what? Base. We take one of the base according to the multiplication law. Going by it, we have ms minus 2, which is what? Our acceleration. Then it can also be put in the same way, like m raised to power s raised to m meter per second raised to power what? 2. Then if you convert it to base unit, it will be ms raised to power minus 2. Then our dimension we have which is what? Length. Then S, which is what? T. Our S, which is what? T. That is what? Time minus 2. Okay. It can also be like this. Which is what? Our mass, which is kilogram, which we don't have because it's not in existence. We represent it with what? Small 0, L, T minus 2. This is what? Our dimension for acceleration. Let's go back to work or energy. Work or energy is force times distance. Force times distance. Then our force is K G times M S minus raised to the power minus 2, which is what? Our force times distance. Our distance is what? M. Okay. When you multiply it together, we have K G times M 2 times S raised to the power minus 2. So our force is what? In joules. Work is what? In joules, represented with letter H. Okay. Then we have our base unit, which is what? K G M square. Then S raised to the power minus 2. Then we have our dimension, which is what? M in kilogram. Then L to T raised to the power what? Minus 2, which is what? Our work or energy. Then, okay, let's continue with force. Force, the definition is mass times acceleration. Okay, we have our mass, which is what? Kg, times our acceleration, which is ms raised to the power minus 2. If we attach it together, we have kg. This dot here is multiplication sign. Any place you see dot in mathematics, know it's what? Multiplication what? Sign times ms minus ms raised to the power minus 2. Okay, this is our definition. Then the SI unit of force is what? Newton. Newton represented with capital letter N. We have our base unit, which is what? Kg ms minus 2, or kg dot m dot s minus 2. Still what? The same thing. Then our dimension, we have our kg, which is what? Our mass. Then we have our meter, which is what? Our length. We have our time, which is what? Our second, which is what? Our time. Representing it here, we have m L T minus 2. Okay, this is our dimension. Another one is what? Pressure. Is what? Pressure. Pressure, we have pressure is force divided by area. That is the definition. We have our force as kg times ms raised to the power 2. Then divided by our area, which is m times m. Then we divide. We have kg times s raised to the power minus 2 over m, which will give us kg. When this m cross over to this side, it will be times m, because of the fourth law of the seventh law of unity, which is negative index, it will be minus 1 times s raised to power minus 2. This is our what? Our pressure. Then the pressure is represented with what? Pascal, with symbol of PAL. Then our base index presenting here is K, G, M minus 1, S minus 2. Then our dimension M, L minus 1, T minus 2. This is our dimension. I2. Then another one we go over is what? Momentum. Okay, power. Power is work over time. We have gotten our work as kg m square s raised to power 2 divided by what? S. This thing will give us this, it will give us this, which is, this thing will give us this, which is kg m square s raised to power minus 2 times s minus 1, okay, which will give us kg m square s, using the first law of unity, which is multiplication law, will give us minus 3. Okay, so our ISI unit is what? In watts, presented with capital letter W. Then our base unit is kg m square s raised to power minus 3. Then our dimension is m l 2 t minus 3. This is our dimension. Solve for momentum. And solve for density. Okay, let me give you the definition. Mass times velocity, then mass times mass divided by volume. This is the definition of velocity and density. Then solve. Then after solving, you provide your answer in the comment section. This is all for today. Thank you for being part of this class. Please follow us on all social media handles as Scripture Learning Center